Okay, people, we're going to do a little math lesson. Here we go. So, as we've learned in the past, we can find a perimeter by measuring the outside of something, like the fence, and we could find the area by finding out how much space is taken up inside. For example, if we had these tiles and we made a shape, it would be like the flooring in a house. We would times the length by the width, and that would tell us how many tiles are inside. Nice and simple. It doesn't matter how big our area is, we can times the length one side by the width the other side, and that will tell us the area. Now, what if I turned one of these tiles, a flat floor tile, into a cube? 3 sides. A tile is 2-dimensional, length and width. For our area, for this one, we would go 2 times 3 equals 6, let's say, meters squared. 2 dimensions, length and width. Now, in this cube, how many dimensions are there? Well, there are 3 dimensions. 3 dimensions in this cube. We have length, we have width, length, width, but we also have height. So not only do we have our floor tiles, length and width, now with a cube we have height. And we can think of that in the room you are in right now. We have the length of one wall, we have the width of another wall, but we are 3-dimensional. We also have height from the floor to ceiling. We can take up this entire space. And this is called volume. Volume. How much space is taken up an entire room? So once again, we have our length, our width, and straight up and down is our height. Length, width, straight up and down is height. How many cubes could you fit into a space? Now, it's really important that we think of cubes as a perfect cube, not a rectangular cube that has longer sides and it's stretched out, but the length, the width, and the height are all the exact same. So let's do an example here. We're going to make a base. So the base of this rectangular prism, well, let's see. It has a length. It has a width. Does it have a height? Yes, it does. The length is 2. The width is 3. What about the height? Well, the height is only 1 cube. It has a length of 2, a width of 3, and a height of 1. So I'm wondering, how much space does this cube take up? Well, we could count them, right? 1, 2, 3, 4, 5, 6. 6. Now let's say we're talking in meters. Each of these cubes is 1 meter by 1 meter by 1 meter. So this would be 6 meters. Well, that's not fully true. When we talked about our tiles, we talked about squared, 2-dimensional. When we talk about our cubes, 3-dimensional. So we're going to call it cubed. 6 meters cubed. 1, 2, 3, 4, 5, 6 meters cubed. 3 sides that we're worried about. 3 dimensions. Now, I wonder if we could make this into some sort of formula with these 3 numbers. The length being 2, the width being 3, the height being 1. How could we somehow get 6 meters cubed with 2, 3, and 1? Well, what if we did this? We did the length times the height the length times the height equals 2 times 3 equals 6. But hold on, what about this height? Well, we only have one layer. This rectangular prism, this little cubey thing here, only has one layer. So if we went 2 times 3 equals 6 times our height, which is only 1, we end up with 6. What if we add another layer? There we go. Well, let's think about this. Our length stays the same. It's still 1, 2 cubes long. It's still 1, 2, 3 cubes in width. But what about height now? What is our height? Well, we can count. We have 1, 2 cubes high. We can look it over here. 1, 2 cubes high. Our height is now 2 cubes, not 1. So let's try out that formula. Well, our length is the same times our width is the same. 2 times 3 equals 6. That gives us the bottom layer, but now we have 2 layers. We have 2 groups of layers. So our height is 2. We're going to times it by our height. 2 times 3 times 2. Well, 2 times 3 is 6. Bring this down, times 2. Oh, that's not a 6. There we go. 6 times 2 equals 12 meters cubed. So if we went ahead and counted all the cubes in here, we would know there's 12. The bottom layer has 6, and then the top layer has 6. 6, 2 groups of 6 equals 12. What if we added a third layer on there? Okay, now, what is our length? Our length is still 2. 1, 2. What about our width? 1, 2, 3. Our width is still 3. Now, what about our height? Straight up and down. We can count how many cubes we have going in height. 1, 2, 3. So our height equals 3. Let's try our formula. We're going to start again with our length times our width, as if we're just figuring out the base, the bottom layer. So 2 times 3 equals 6. Our bottom layer is still 6 cubes. But we're also thinking we have to think of height for our 3D. Let's count how many cubes up. 1, 2, 3. 3 groups of 6. Our bottom layer is 6. We have 3 groups of it. 6 times 3 layers. 6 times 3. 18 what? Meters cubed. If we counted all the blocks in here, we'd have 18. We have 1 layer of 6, another layer of 6 is 12, and another layer of 6 is 18. 18 meters cubed, because this is a cube. It has 3 dimensions, length, width, and height. Let's do a completely new cube. Okay, we're going to find the volume of this shape right here. What do we need to do? Well, we need to find the length, the width, and the height. So let's count the width. 1, 2, 3. Our length equals 3. Let's count our width. 1, 2, 3, 4, 5. Our width. Oh, that's right in the shadow. That's not a 5 either anyway. Our width is 5. What about our height? Well, it's only 1 layer, so our height is 1. 3 by 5 by 1 high. So to find the volume of this first layer, we would go our length times width times height. Length is 3 times 5. Technically times 1, so let's do that. Times 1 high, it's only 1 high, equals, well, 3 times 5 is 15. One group of 15 is still 15, so our answer is 15 meters cubed. 3 dimensions cubed. We're still pretending like one of these cubes here is 1 meter by 1 meter by 1 meter. Let's add a second layer on top of this. Okay, now we've added a second layer. We've made our shape a little bit taller. Let's think about our length. Well, it's still 1, 2, 3. 3 wide, or 3 in length. 1, 2, 3, 4, 5 in width. What about height now? Well, we've added a second layer. We have 2 meters high. 2 in height. So let's use our formula here. Let's find our base layer first. 3 times 5. And how many layers do we have? Well, we have 2 layers now. 1, 2 high. So we're going to do 2 layers times 2. Our length times our width times our height. 3 times 5 equals 15. But we have 2 layers. So 15 times 2 is 30 meters cubed. So we're using a representation here. Obviously, this is not 1 meter in length by 1 meter in width by 1 meter high. We're pretending like it is. Of course, we could do volume in feet cubed, or centimeters cubed, or inches cubed, or kilometers cubed. Let's say we wanted to find the volume of the entire airspace of Canada above it. We could do kilometers cubed. 1 kilometer in length, 1 kilometer in width by 1 kilometer high. A massive, massive cube. And we could see how many cubes fit in. So if I was thinking about this room, you know, I could grab a meter stick. I could go get some cardboard and make a huge cube box that is 1 meter in height, 1 meter in width, and 1 meter in length, and make a big cube. And I could see how many of those cubes would fit into this room. How much space is taken up from floor to ceiling, wall to wall, wall to wall? 3 dimensions. So what I would like you to do is this. So the first question, what is the volume of this shape right here? It has a length of 2, a width of 2, and a height of 2. Please put that into a formula. If you need a little help, we're going to go length times width times height, which would be 2 times 2 for our base layer, 2 times 2, but then we have our height. We have 2 layers. So times 2 layers equals what? And don't forget the cubed, 3 dimensions. Then you're going to make your own cube. You can draw it out if you'd like. The length is going to be 4. The width is going to be 5. And the height is going to be 3. So we have a shape here, an object here. I want you to try and draw it out. You can build it or visualize it. But the length is going to be 4. The width is going to be 5. And the height, going up and down, is going to be 3. Okay, so that's your next one. And then, finally, I want you to find the volume in meters or feet of a room in your house. So for that, you could use a meter stick. You could use a tape measure that has feet. You're going to have to measure the length of a room, the width of a room, and the height of your room. Now, if you're doing meters, it's probably not going to be exactly 7 meters, but you can round it. So if it's at 6.78 meters, you can just round it to 7 meters. That's okay. Same with feet. Do whatever's close. If it's between 11 and 12, just choose one of them. I want you to find the length, the width, and measure the height so you can find the space inside the room. There it is again. Volume is 3D. We need to find the length and the width to find the base, that first layer, and then we find the height and we multiply it. The length times the width by the height. We're multiplying the base layer by however many layers on top. So that is volume. We'll do lots of practice, and then we're going to get into a big project. Please complete those 3 questions. Number 1, number 2, and number 3, finding the volume of a room in your house. Then you need to take a picture of them and submit them into your personal math folder, not the class math folder, your personal one. You can find it in your Google Classroom. Go to math, go to math folder, find your name, insert it into there. That's volume.